Hi, welcome to our project. Have you ever wondered how much your house would be worth? Imagine that you are a group of college students and you're completely uneducated about housing price in Providence. This was the situation that our group was in at the start of this semester before we decided on our data science final project. Because we're all living in Providence as college students, we were very interested in investigating housing prices and how different properties affect housing prices. Home buying is actually a really big part in a lot of people's lives, but the process is often very opaque, with information asymmetry on both the buyer and seller side. In this project, we try to use existing data to analyze the Providence housing market, find out how each factor from year built to location to number of bedrooms influences the housing price. Finally, we have made the result transparent and accessible to the public through an interactive web application.
Regarding solving the problem of predicting housing prices based on the available housing attributes that we got from Redfin, we used a machine learning model to predict a target sale price variable based on 13 to 14 housing attribute variables. And to do this, we use the TensorFlow sequential model with 4 dense layers using ReLU activation functions. Regarding pre-processing, we cross-validated the data set into an 80-20 split, as well as applying min-max normalization to the sale price from 0 to 100. And we trained the model over 100 epochs with a learning rate of 0.0025. And the results are, as you can see on figure 1. If we look closely, we'll see that there is on the x-axis a % difference and on the y-axis a % distribution. This graph shows on average the % difference that the predictions were off by. So we can see that the majority of predictions are within a 0 to 40% error margin, which is an acceptable range considering that most of the prices are several $100,000, though there are some outliers that go even up to 300 to 400%. We believe that this is because of the flawed data set. There are housing units that sold for extremely high prices or extremely low prices. Our model has difficulty in predicting those kinds of abnormal housing units because of the lack of data. But we believe that for most normal housing units, our machine learning model does really well in predicting the price of the housing unit, given just some of the housing attributes, which is why we are satisfied with the model.
So for our project, we had several hypotheses that we wanted to test regarding property attributes and their relationship with sale price. The first hypothesis we looked at was whether there is a significant difference in the sale price of houses with 1-story compared to all other houses. And to determine the significance of 1-story house sale prices, we group properties based on the number of stories and use a 1-sample z-test to compare the sample mean, which is the sale price of houses with 1-story, with the population mean, which is just the sale price of all houses. And we discovered that houses with a single story tend to have a smaller square footage, which means they have a lower sale price because a smaller living area is being sold in general. So if we look at figure 2 in our poster, we can see that these 3 graphs show the relationships between square footage, number of stories, and sale price. And in general, the trend is as the number of stories goes up, the square footage goes up, and the sale price goes up as well. The second hypothesis we looked at was on whether there was a significant relationship in the sale price of houses built in the 1900s compared to houses built in the 2000s. To compare these sale prices, we split the properties based on the year built, and we use a 2-sample z-test to test if there was a statistical difference between the 2 sample means, which would be the sale price of houses built in the 1900s and the sale price of houses built in the 2000s. And we discovered there is a significant difference in these sale prices. Houses built in the 2000s tend to be more expensive. The average sale price for houses built in the 2000s is around $304,000, while the average sale price for houses built in the 1900s is around $280,000. And the last hypothesis that we looked at was on whether there is a relationship between properties with a high bike score and properties with a high walk score. And to determine the relationship between these properties, we generated a cross table indicating which properties had a high walk or bike score, which we defined a high walk or bike score as a score above 50. And we used a chi-square contingency test to test the relationship between these two categorical variables. And we discovered that there is a significant relationship between properties with a high bike score and high walk score. Properties with a high bike score and properties with a high walk score are positively correlated, as you can see in figure 3 here. And this suggests that houses with a good environment for walking likely also have a good environment for biking and vice versa.
And so now we come to the web app that we have developed to showcase and have users interact with all of the data that we've gathered. So on this web app, we first have an about section, which talks a little bit about what the tool is for, which is to predict housing prices given user input. And for this prediction, we have taken the liberty of assigning some default values to properties that the user will have a hard time predicting or estimating, such as storm risk, heat risk, or certain Redfin values like walk score. So we've taken the default values to be the mode of each data point in our data set. The instructions for using the predictor is fairly self-explanatory. Users have to fill out all of the fields, and when they hit get price down here, they would obtain an estimated price for their imaginary or real house. So let's give it a spin. Let's say Sally has a house that has 3,000 square feet of area and a lot of double that, 6,000 square feet. It was built back in 1986. It has 3 beds, 3 baths, and has 2 stories. She's listed it on Zillow for 60 days and hasn't had an offer yet. She wants to see how much could this potentially sell for. Let's try clicking get price. So we see we've obtained the number of $598,000. This is interesting, but what's more interesting is when we start to play around with some of the numbers here. Let's say we increase the lot size to 10,000 square foot. We should expect the price to increase, and it does. And what if the area of Sally's house was smaller? Let's say it only had 1,000 square footage. And now the housing price is a lot cheaper. This tool not only gives people a rough estimate of what kind of house with these attributes would cost in the Providence area, but also the relationship between the housing price and all of these attributes that we have. We do put a disclaimer at the bottom saying it is strictly for educational purposes and not for financial advice, in the case anyone mistakes this for real housing data, because it is, after all, just a predictor. The way we do this web app, the way we built it, is that there is a React front end that does all of the forms, data validation, cleansing, and it sends the data to a front end located TensorFlow.js model. And that model was pre-trained in Python and imported into the front end to do all of the inference.
We faced several challenges with this project. The first one we faced was cleaning the data and getting rid of all outliers. Although we cleaned our data by removing rows with excessive null values and removed properties that could be considered outliers, there were several hidden anomalies that we were unable to identify and remove. These outliers affected our results, especially the predictions of our model. Second, several of our p-values from our statistical test were extremely small. Although these values were unusual, we found no issues with our code and were able to confirm our results with other calculations and visualizations. This anomaly is important to keep in mind when interpreting our results. We also faced several limitations. First, our data is sourced from Redfin. Although certain attributes are required to put up a listing, most attributes submitted by users are actually optional. This indicates that our data accuracy is heavily reliant on users. In addition, the model is limited to predictions for houses in the Providence area due to the defined parameters of the project. Furthermore, not all data on housing sold in Providence is available on Redfin. Thus, the data might be incomplete and skewed towards housing units that are more likely to be listed on sites like Redfin. Nevertheless, Redfin is a very popular website for housing. Therefore, we believe that this makes our data fairly comprehensive and one of the best sources of data we have in this field. Therefore, as a conclusion, we believe that our findings can serve as a meaningful tool in discovering and interpreting property attributes and their relationship with housing price patterns. As group members working on this project, all of us were more educated about housing prices after this project, and we sincerely hope that our users will do the same.
When conducting our research on the social, historical, and impact report, we realized that the housing market has deep ethical issues that significantly impact home buyers. While certain property attributes may seem insignificant to some, these attributes can be major deciding factors for other buyers. For example, poorer home buyers may need to carefully consider the year the desired property was built. Based on our statistical testing, we discovered that older houses tend to be cheaper. However, they require more maintenance, which can be a big economic burden in the long run. To further expand on our project, we would like to do more research on the socio-historical context of housing in Providence and specifically curate our hypotheses to address these issues. This can help us draw more significant conclusions from our work. In addition, while working on our project, we noticed that several outliers, like properties that weren't officially considered houses, properties with odd attributes, or properties with extreme pricings, impacted the accuracy of our results, especially the results of our prediction model. For example, there were Redfin data points that were selling large stretches of empty land as house property type. Therefore, to improve on our project, we would like to further clean out data, perhaps by looking at the entire price by foot and weeding out the extreme outliers. Lastly, we confined our data to the Providence area to make the scope of the project more manageable. However, we are interested in looking at housing data in different locations and exploring how the impact of different attributes can change based on location. We can also scrape more websites like Zillow for more in-depth information to conduct analysis on. Thank you for watching our presentation.